Hello friends, in this video we are going to discuss the third numerical related with the gate characteristic of SCR. So let us read the example carefully. With a gate cathode voltage constant at 5 volt, the gate current of a thyristor is observed to be 0.1 ampere. If gate pulses of duty cycle 0.7 are used, the average gate power dissipation in watts is, okay, so they have asked, okay, so our task is to find the average gate power dissipation and they have given the 4 options, okay. So please first note the given data, okay. So I am writing here the solution. Yes, gate cathode voltage, that is the Vg, is equal to 5 volt. It is a constant, right? So Vg is equal to 5 volt. It is a constant. The gate current of the thyristor is observed to be 0.1 ampere. If gate pulses of duty cycle 0.7 are used, okay, the average gate power dissipation. So we need to find Pg average, right? So please be careful. It is given that the Vg, we are having the constant voltage. Vg is constant voltage. It is a time t 0, right? So it is a 5 volt constant voltage. So this voltage is equal to 5 volt. What is the Ig? Ig is equal to 0.1 ampere, but at the same time it is given that if the gate pulses of duty cycle 0.7, okay. So duty cycle means what? Duty cycle is nothing but the on time divided by total time, on time divided by total time, okay. So 0.7 duty cycle means what? Yes, suppose this is a 0.1 ampere and at this, after that again it will be 0 and again non-zero, okay. In this same way it goes on repeating, okay. So it is like this is a t, this is a 2t, okay, and it indicates 0.7t, okay, and it is 1.7t, okay. So if you check whatever the pulse here, the same pulse is repeating here, right? So what is the period? Period is capital T and on time is 0.7t. As I said, the duty cycle is on time, that is a 0.7t divided by the total time. So it is a 0.7t by t, so it is a 0.7, okay. So what is the magnitude of the gate current? It is a 0.1. It is a 0.1 ampere. So from this VGIG we can draw the PG curve, right? So PG we are having. So we can draw PG, okay. So is equal to Vg into Ig. Pg is equal to Vg into Ig, okay. So if you check, it is a 0.1, it is a 5. So during this interval, right, it is a 5 into 0.1, so it is a 0.5, right? Again 0. Here 0 into 5, so it is a 0. After that again, this is 0.5, again 0, right? And same, it goes on, okay. What is this magnitude? This is 0.5 watt actually, okay. 0.5. This is 0.02.7 t. This is t. This is 1.7 t and 2t, right? Now we need to find the average, PG average. How we can find the average? Suppose we are having the 10 numbers 1 to 10. How generally we take the average? We add the numbers 1 plus 2 plus 3 up to the 10 divided by number of total count, that is divided by the total numbers, that is a 10, okay. So here we are having 0 to 0.70 means during this interval we are having the infinite samples. Be careful, this is the continuous signal. So in the continuous signal we are having the infinite samples. So is it possible to add the infinite numbers manually? Not possible. So in that case generally we take the help of the mathematical operator integrator, okay. So here we are going to integrate this number, okay, or this magnitude over the interval 0 to 0.70. And what is the total period? Total period is t, okay. So how we take? It is equal to 1 by t integration from 0 to 0.7t. What is the value? 0.5 into dt. So if we simplify it, yes, we can get it as a 0.5 into 0.7t divided by t. T will get cancel. So it is a 0.5 into 0.7. So it is a 0.35 watts. Okay, so this is the final answer, PG average, which is equal to 0.35 watts. Are you getting the point? Is this clear? Okay, so this is about the numerical 3, right? Correct answer is option B. Correct answer is option B. Okay, so in the next video we'll discuss about the two transistor analogy of SCR. Thank you.